This year, the number of accidents X at an amusement park has probability generating function PXT is equal to this. The amusement park's owner's insurance company reimburses up to a maximum of 1 accident this year. Let Y be the number of unreimbursed accidents. Determine the PGF of the number of unreimbursed accidents at this amusement park this year. Okay, so PGF is a shorthand that I will be using for probability generating function. So this is the first problem in which we are encountering probability generating function. So let's briefly talk about what it is. Probability generating function generating function. So here, let's use the same notation that they are using in this problem. They're using pxt for the probability generating function of x. So if x is a random variable, its PGF is so let's denote by capital P subscript x of t is equal to, so basically it's the expected value of t power x. And if, so that's for any random variable, and if x takes only non-negative integer values, then we know we will basically, that means that also implies that x is a discrete random variable. So in this case, we just use the formula for the expected value when we are dealing with a discrete random variable. So it would just be the summation of, so we know that expected value of x is just summation of x times the probability function. And so the expected value of e to the tx would just be t to the x times the probability function of x. Where x is the probability mass function of x, where f of x is the probability mass function of x. Okay, so the reason why this is called probability generating function is that we can see from here that it gives the coefficients. If we expand this summation out, so let's expand it out to see what this one looks like. So in this case, the summation would be from x is equal to 0 to infinity. We're talking about x taking non-negative integer values. So therefore, pxt, when we open this summation, so when we put x is equal to 0, that's t power 0 is 1. So that's just f of 0 plus, and then when you put x equals 1, we get t power 1, f of 1 plus, and when we put x equals 2, we get t power 2, f of 2 plus so on. And so we see that f of 0 is the probability at x is equal to 0, that x is equal to 0. F of 1 is the probability that x is equal to 1. So let's just write down, recall that f of 0 equals probability x is equal to 0. Similarly, f of 1 is probability x is equal to 1. And so on. So once again, let's rewrite it. We had the probability generating function of x was, let's go back to the previous screen. F of 0 plus t, f of 1 plus t square, f of 2, so on. F of 0 plus t, f of 1 plus t square, f of 2, and so on. Okay. And in this case, now let's return to the problem. In this case, we are given that pxt is equal to e power negative 0.2 times 1 minus t. So here, pxt equal to e power negative 2, 1 minus t.
It's negative 0.2.
Okay, negative 0.2. Negative 0.2, 1 minus t. Okay, thank you. And x is the number of accidents that happen. Y, and the amusement park's owner's insurance company reimburses up to a maximum of 1 accident. So Y is the number of unreimbursed accidents. So let's first discover a relationship between Y and X. X is the total number of accidents, and Y is the number of unreimbursed accidents. So let's make a little table. X, total accidents, and Y, unreimbursed. Okay. So the total accident could be 0. So if there is 0 accident, then every accident is reimbursed because there is no unreimbursed accident, because there is no accident to begin with. So in this case, every accident is reimbursed. So the unreimbursed accidents are 0. So there is nothing that goes without being reimbursed, because by default, we don't have anything to reimburse. If there is 1 accident, then again, we have 0 unreimbursed accidents, because 1 accident will be reimbursed. We are told that the owner will reimburse, the owner of the insurance company will reimburse up to a maximum of 1 accident, which means if 1 accident happens, then that will be reimbursed. So that means, again, there will be no unreimbursed accidents. But if we have 2 accidents, then only 1 of them will be reimbursed, and that means we'll have 1 unreimbursed accident. Similarly, we have 3 accidents, we'll have 1 of them will be reimbursed, means there'll be 2 that will be not reimbursed, and so on. Now we see the pattern. This is 4, this is 3, and so on. This goes on. Okay. So the question is to find the PGF of Y. Okay. So the PGF of y, by definition, let's open new window. So we have to find PGF of y, which is denoted by P subscript YT. And again, by definition, if we look at the expansion that we came up with, let me show you that again. So this was the expansion for the pxt. It was f of 0 plus t f of 1 plus t square f of 2. So in this case, it would be, let's call the probability function of y as g. So be g of 0 plus t g of 1 plus t squared g of 2 and so on. So g of 0 plus t g of 1 plus t squared g of 2 plus so on, where g of y is the PMF of y. So this is what we have to find. So g of 0 is its probability y is equal to 0. Like we said, that over here, we said like f of 1 is probability x is equal to 1. So any PMF value is the probability at that random variable value. So the question is, what is probability y is equal to 0? So now if we look at that little table that we made, so we are trying to find probability y is equal to 0. So that little table tells us that y is equal to 0 when x is equal to 0 or x is equal to 1. These are the only two situations when y is 0. So the probability y is equal to 0 is the same as probability x is equal to 0 or 1, and we know that or means addition. So y is equal to 0 would be x is equal to 0 plus x is equal to 1. It's equal to probability x is equal to 0 plus probability x is equal to 1. And now these can be calculated from, actually, we just need probability x is equal to 0. So let's just leave it like that over here. So let's look at the other g values. So if we now substitute this in, so pyt. So this equation is, the first term is g of 0, which we figured out is these two terms, probability x is equal to 0 plus probability x is equal to 1 plus tg of 1. So t probable, and g of 1 is probability y is equal to 1. Plus t squared g of 2, and g of 2 is probability y is equal to 2. So on. And now this would be probability x is equal to 0 plus probability. So now we want to change everything into x because we have the probability generating function of x. So right now these two are already in x. Here we also want to change the y into x. So for this, we again look at our little table. So probability y is equal to 1. So let's go back to our table. So y is equal to 1 only when x is equal to 2. So y is equal to 1 is the same as x is equal to 2. I mean, the probability y is equal to 1 means probability x equals to 2. Oh, so no, the x is equal to 1 was already there, this one. And then we have t, and here y, this one, y is equal to 1 means x is equal to 2. So this would be probability x is equal to 2. Plus t square probability, and y is equal to 2 will mean x is equal to 3 if we look in our little table. So y is equal to 2 is this, and that's corresponding to x is equal to 3. Okay. And we actually can see the pattern here. We can write one more term if we want. So that's t cube probability x is equal to 4, and so on. So now what will happen is that this probability x is equal to 0, let's just write it as a separate term. Plus, and now let's change these back into f's. So this is f of 1 plus t f of 2 plus t square f of 3, because now since we have the x, therefore the probability function for the x was the f. Okay, so this one is so now the issue here is we would be in great shape if these powers were matching with these numbers, but right now we are one off. So we would love to have t squared with f of 2, t cubed with f of 3, and so on, because that way this whole expansion will take the form of the probability generating function. We go back and look at how it looks like. So you see in the probability generating function, the powers of t match with this argument. So when you have t power 2, the argument is 2. When we have t power 1, the argument is 1. And so then the whole thing becomes the probability generating functions. The issue here is we are off by 1 power. So with t power 1, we have f of 2. With t power 2, we have f of 3, and so on. So what we will do is, to take care of that, we will do 1 over t. And then this would become t f of 1 plus t square f of 2 plus t cube f of 3 plus so on. And that's what we wanted. Okay. So still we are missing one thing. We are missing f of 0 here. And now you see that why we kept this one as separate. This is f of 0. We could not have included this one and this sum, because if you had divided by t, then you would have had to put a t with this one as well. Whereas in the expansion, the f of 0 does not have a t with it. So in fact, it's easier if we change this also to f of 0. So with the f of 0, we don't want any coefficient. That's why I kept it out of this 1 over t business. Because if we look back again, see f of 0 is by itself. We have a tf1, t square f2, and that's what we are getting here. So again, we'll have to open another one. So let's just remember this is f of 0 plus 1 over t, and then we have the correct terms. So the left-hand side was py t, and it was equal to f of 0. And then we had a 1 over t. And then we had tf of 1 plus t square f of 2 plus so on. Now, the thing is that this is almost what we want. But it is missing the f of 0 term. So if we compare it with the form that we want, so we have tf of 1, t square f of 2, and so on, tf of 1, t square f of 2. But in order for it to be the PGF, we also have to have f of 0 added on. So we are missing the f of 0 in that bracket. So that's not a problem. So we have this beginning f of 0. And so in this bracket, we are missing f of 0 because other than that, this whole expansion would be the PGF of x. So to write the missing f of 0, we subtract f of 0 and add f of 0. So that means we have added nothing. And then tf of 1 plus t square f of 2 plus so on. So now this part starting from here and here, that is just the PGF of x. If we look at the PGF of x, that's f of 0 plus tf of 1 plus t square f of 2. So let's write it. F of 0 plus 1 over t minus f of 0. And this part is the remaining part is the PGF of x. So that'd be p xt. So now we can substitute the formula for pxt, which was given in the problem. This was the problem. This was the formula that was given in the problem. If you look at the answers are of this form involving a term like this. And so pxt can be substituted. And then we need f of 0. But again, f of 0 is easy to find. So let's just rewrite what the pxt was. Pxt is e to the negative 0.2, 1 minus t. Pxt e to the negative 0.2, 1 minus t. And we know that from here, if we look at that expansion, so we can get the px0 here, px0, because px0 is basically f of 0. Px0 is f of 0 equals e to the negative 0.2, 1 minus 0, negative 0.2. Okay, let's understand why px0 is f of 0. So if we go back to what the PGF looks like. So here, if we substitute t is equal to 0, then we will get f of 0 on the right side, and here t is equal to 0, so this term zeroes out. Here again, we have a t, this zeroes out. So you see, every term except the first term will disappear when we substitute t is equal to 0, because the remaining terms after the first term all have t's in them, so multiplying by 0. So therefore, from here we can see that px0 is equal to f of 0. That's true for any probability generating function. So therefore, px0 gives us the f of 0 that we need in this equation, and that's e power negative 0.2. And now we have everything. We have f of 0, which is e power negative 0.2, and we have pxt, which is the given expression, and now we'll substitute that in this pyt equation. So therefore, pyt is equal to f of 0. So f of 0 is e to the negative 0.2 plus 1 over t negative e to the negative 0.2, and then the pxt is e to the 0.2 minus t. And now this would be a correct answer in a written exam, but of course here we have to pick up the correct multiple choice answer. And now if we go back and look at our answers, so we see the answers. So there's definitely a dividing t, which we are seeing over here. But here we have the t being over this this part of the answer, but not over this, this part. So that means that, so we already know that it cannot be the first two. It has to be either C, D, or E, because these are the ones that have t underneath, but they all are combined into a single fraction. And therefore, that's our next step. We need to combine this into a single fraction. So t is the common denominator. And this here, this t will multiply here. So it'll be t e to the negative 0.2 minus e to the negative 0.2 minus e to the 0.2, 1 minus t. And now here, if we look at the choices, so it cannot be the first. So it looks like this one. So here we have an e to the negative 0.2 factored out, and we get t minus 1. So let's do the same there. So in the first two terms, you can factor out an e to the negative 0.2. You get t minus 1. So that takes care of the first two terms, and then the last term is minus e to the negative 0.2, 1 minus t, and we had all over t. And that, I think, was choice E. Yeah. Oh, well, this is a plus here. So let's see. Oh, actually, this was a plus. So I somehow wrote this as a minus. This negative was not a distributing negative. It was here. So this is a plus. So this is a plus. And that is choice E. So I hope this is clear.